back into. Hey everyone, I'm back. I was going to give up on the flat earth debate, but when I saw Dave and Craig thinking that they schooled David Weiss, I had to get back into it. I thought maybe I'm making things too complicated to try to explain it to these eggheads. So I'm going to make it simple. I'm going to use the tools that I used in second grade to figure out that we weren't spinning through space. First of all, let's look at throwing a ball out the back of a pickup truck. If we have a truck driving east at 60 miles per hour and a pitcher that's throwing west at 45 miles per hour, the ball's never going to go west, not an inch.
What would happen if the Earth stopped rotating for a second?
Oh, yeah, that would be disastrous. Disastrous, because right now, here in New York, you can calculate at our latitude, we are all moving with the Earth at 800 miles an hour, due east, because Earth is rotating. If you stopped Earth and you were seatbelt buckled to the Earth, you would fall over and roll 800 miles an hour due east. It would kill everyone on Earth. People would be flying out of windows, and that would just be a bad day on Earth. I'm just saying.
Globeheads totally ignore the momentum and stored energy they would have due to the velocity of rotating along with the Earth. What would happen if Professor Dave was hanging out doing whatever he does, and Craig came along and ran into him at 10 miles per hour, or 40, or 80, or 1,000? Now let's put a scraper on the Earth that's just 1 inch above the surface of the Earth, and we'll give Craig the ability to run 1,000 miles per hour. Here's a cool thought experiment if you can keep up. Craig and Dave, you better sit this one out. Here I've grabbed a plane trying to fly east and taken away all its momentum. Next, I'm going to give it a 500 mile per hour boost next to another jet that's taking off. Now here is a mind-boggler. This plane's not going to make it to its destination because it can't fly fast enough. Both of these planes took off at 500 miles per hour from the same place, but we took away this plane's extra that it got from the rotation of the Earth. Yeah, it's not going to make it to its destination. But this one is. They're both flying 500 miles per hour, but this one's not going to make it. But this one is. Now, if you think that's crazy, check this out. My friend knows a pilot, and he told me not to share the story, but I'm going to anyway. The pilot is flying east in a jet that only does 500 miles per hour. Fortunately, he's got the extra 1,000 from the Earth. And the pilot is with passengers and everything. He's 2 hours into his flight east, and he realizes he left something at the airport that he just has to have. He turns around, and going back against the momentum that he got from the Earth, he's going full throttle. He's thrusting back to get to the airport. He gets 2 hours back to the airport, and he realizes he didn't leave what he thought he did. Turns the jet around and starts flying east again. He gets about an hour out, and he's like, wait a minute. He did leave what he wanted. So he turns around again, and for the second time, he thrusts back against the momentum that he got from the Earth, gets to the airport again, and realizes he's got the shit right in his pocket. And he's like, wow, but you're never going to guess what. He turns around, he starts flying east again. You're not going to believe what happened. You ain't going to believe what happened. He got the 1,000 miles per hour back. It was just like magic. It was right there. Boom. As soon as he turned around, boom, he had it back. Is that nuts or what? That's just crazy. Oh, man. Man, that's crazy. Do I believe in conspiracies? No. I've got my mind on too many other things, like how much wood can a woodchuck really chuck? Do they really chuck wood? No. I'll tell you what does bother me. Some of the shoddy construction work I've seen. It's time for a mystery moment. See if you can guess what this is. Here we'll pan out a bit. Did you guess shoddy construction work? Well, you got it. Ding, 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 ding. Winner, winner. No flat earther takes it lightly. Because the first thing you've got to consider is that NASA would have to be fake. Completely fake. And you consider that, and then you find stuff like this. Dave and Craig, you might want to take a break. Here's another thought experiment I don't think you'll like. Pour yourself some Kool-Aid, have some Pop-Tarts, do whatever you do. For the rest of you, here we have a parked car and a car driving west. How is it that when a collision happens between a car that's parked and someone drives into it, that no matter what direction they're traveling, it'll knock that parked car out of its parking spot? But it would take over 2,000 miles per hour to do that if the car was driving west. Quick apology to everyone that thinks on their feet and uses their brain correctly, uses their knowledge of physics correctly. In case Craig and Dave are trying to keep up, I keep calling him Dave just because he's not a professor, so that's why, for that. Talk about deceiving. Just in case they're trying to keep up, and they might be wondering, why 2,000 miles per hour? Why would the car have to be driving 2,000 miles per hour to get into an equal head-on collision? Well, because if it was driving 1,000 miles per hour, it would look like this. A car driving west 1,000 miles per hour would have no momentum, and you're about to be hit by a parked car that's got a bunch of it. Consider these facts and see if you can answer a bonus question. There's no prize, but you just might learn something. This animation is an exact representation of what this collision would look like from space. We have added a continuous road around the equator and indestructible cars, as they will not affect the results we are trying to observe. Both cars are the same weight. Both cars will travel the same distance in a 12-hour period. Both cars have the same velocity. Both cars will have the exact same momentum when they collide. The only advantage is for the parked car. Its wheels are firmly on the ground, and the direction of motion is working in its favor. Bonus question. Do the laws of motion recognize the intricacies of the cars in motion? And do the laws of motion care how or where an object in motion gets its motion? Here is your only clue. No. We're going to observe two different runners. Pay particular attention to the momentum. Here we have Johnson, who just set a new record in the 50-yard dash. Here's Erica running 20 miles per hour on a treadmill. She has no momentum when she steps off the treadmill. He's probably still stopping today. We know that the laws of motion are the same in every frame of reference. So there's a problem here. Erica and Johnson are both running 20 miles per hour. Erica and Johnson are both running on a moving surface. So why is it that Johnson can run in any direction and have momentum that he has to slow down? But Erica, when she's running, she has no momentum in one direction, but if we were to extend the treadmill and turn her around and she were to run with the treadmill, she would have 40 miles per hour of momentum. She would have her 20 miles per hour plus the belt's 20 miles per hour. So what's going on here? Ernst Mach said that a good thought experiment would render any physical experimentation, render it unnecessary. I'm going to show you how to do a good thought experiment. Similar to math, where you find a common denominator to make difficult fractions very easy to work with, we're going to do the same. I'll show you. But first, hey Craig, do you like dogs? How about cats? Cats, now you were a school teacher, is that right? Would you like to tell everyone where the error in my thinking is? Craig's running 1,000 miles per hour and he's getting ready to plow you. He's going to plow you good. How far do you think he's going to knock you, cats? For this thought experiment, we go up north to just around the 89th parallel, about 69 miles away from the North Pole. The alleged rotational speed at this parallel is just over 18 miles per hour. So, our runner on the Earth is running 18 miles per hour, and we have, with the help of some aliens, we've suspended a treadmill right next to that runner. On the treadmill, this person is running 18 miles per hour. Just observe the area 5 feet around both runners. There's no difference. There is no difference. Dave and Craig, I'm going to excuse you guys early. You might want to go grab your crying towels. Through this thought experiment, we can correctly deduce that we should experience a difference in our momentum depending on what direction we are traveling. Now we're going to use the same process, only different. This time we're using the Earth to power the treadmill. Now by changing speeds, slowing it down, speeding it up, we can see that there should be absolutely no difference between the experience of running on a moving surface, regardless of what the moving surface is. This is the last time I'm going to say it. If we lived on a spinning Earth, it would be self-evident. Dealing with these guys that, yeah, they think they're traveling through space at 500,000 miles an hour. This subject has been addressed before, but not correctly. If you lived on a spinning globe, you would experience a 2,000 mile per hour change twice a day. Craig addresses this problem with, it's brilliant. He renames it the 1,000 miles per hour. I forget what it is, rounds per day, or he makes it sound slower, and he kind of loses sight of the fact that it's still 1,000 miles per hour. I don't know what the guy's kid's name is, Hitth or whatever, Hith. He broke it down, and he worked it out to, oh, that's only 60 miles per hour over 20 minutes rate of change. Over 20 minutes, you wouldn't feel that. Now, I did the math. We do math. Yeah, we really do. There is an average rate of change of 0.81 inches per second. That's a little different. At points A and B, you are directly perpendicular to the orbital path. That's when you experience 68,000 miles per hour. At point D, you will be traveling 69,000 miles per hour, and at point C, you'll be traveling 67,000 miles per hour. The 0.81 inches of change is the average per second. It's going to be below that, and it's going to be above that. It's not going to be a steady 0.81 inches every second. It's going to start and climb slowly and decrease slowly. So if you turn on an accelerometer, if you turn one on when you're falling, it's just not going to tell you anything. But then if you started falling faster or slower, it would. Well, the accelerometer would easily be able to pick up the difference. Yeah. Think about it. Think about it, Dave. Think about it, Craig. Think about it, Psyman Dan. Think about it, Greater Sapien. Think about it, Wolfie. Think about it, Team Skeptic. Think about it, Godless Tubby. Think about it. At the very least, you're going to have a 0.81 inch lean this way, and then 12 hours later, you're going to have a 0.81 inch lean this way. They got you guys to digest this crap in grade school. Now, myself, I wasn't buying. They pulled me out of my first grade class to test me for advanced placement. I had aced 2 of their advanced placement tests. I don't know if you guys remember that experience of 2 people in suits showing up at your school to pull you out of class to take you to the office for some more special testing. Maybe you do, maybe you don't. But I'll tell you what, at some point, you digested that crap because it meant something to somebody else. Some girl said, "Oh, Dave, do you understand this stuff?" And Dave went, "Yes, I do." And you could have put the information in buckets of puke and Dave would have drank it down. Greater Sapien, you probably impressed your friends. They thought you were really smart because you understood this stuff. You guys didn't understand shit. You knew it didn't make sense, but you wanted it to make sense. You wanted it to make sense. Well, now you know better. Now, from this point on, after this video, if you continue with your crap, well, then you're just being dumb. You're just being dumb. I can tell that you guys are smart enough to figure this out, applying physics correctly. Quit being dumb.